For this video, we're looking for horizontal asymptotes. So if you have a graph and something's going on in the middle, we really don't care. When we care about horizontal asymptotes, are way out on the far edges of the graph, so that would be out towards positive infinity. Or maybe something's going on over here. You could even have a vertical asymptote, it doesn't really matter. But it could also happen as x heads towards negative infinity. So it's happening at the edges of the graph. So to find horizontal asymptotes, I'm going to take the limit as x approaches negative infinity, and I'm going to take the limit as x approaches positive infinity. So the limit as x approaches negative infinity of 5 minus 2 over x squared, and the limit as x approaches positive infinity of 5 minus 2 over x squared. So first step for limit is actually just to evaluate it. Plug in your limit here. So I'm going to say that this is equal to 5 minus 2. Then negative infinity squared is actually a positive infinity. Then I look at this. 2 divided by something humongous is actually very, very small. So this goes to 0. 5 minus 0 is just 5. So I know that I have a horizontal asymptote at y equals 5. For this one, out towards the right, I'm actually going to get the same thing because I'm going to plug infinity in and get 5 minus 2 over infinity goes to 0. And I have the same asymptote. For this graph, it has one horizontal asymptote at y equals 5. If I look at this next graph, y equals 5 minus 2 over x, and I take my limits, I'm going to do the limit as x approaches negative infinity of 5 minus 2 over x. That would equal 5, and then I have a minus 2 divided by a negative number. That's plus infinity. 2 over infinity goes to 0. So I'm still getting y equals 5 as an asymptote. The actual limit itself is 5. To be clear, the asymptote's at y equals 5, so make sure you pay attention to what question's being asked. If I do the limit as x approaches positive infinity, I would have, well, 5 minus 2 over x, I'm going to get 5 minus 2 over infinity. 2 over infinity still goes to 0, so we're approaching 5 from the positive side for this one and the negative side for this one, but it's the same asymptote. So they both have a limit of 5, and my asymptote is y equals 5. For this problem, if I take the limit as x approaches a negative infinity and I plug it in, I'll have 2 times negative infinity is negative infinity minus 1 is negative infinity. Then negative infinity plus 1 is still negative infinity. And don't be fooled into thinking that this is actually 1. This is called an indeterminate form. So if you have infinity over infinity or negative infinity over negative infinity, there are ways to evaluate it, but we aren't really sure just by looking at this. So there's 2 different ways to approach this. One is to find the highest power of x that's here. And I'm actually just caring about the denominator, the highest power of x in the denominator, but it's an x to the first. And I'm going to go divide each term by that x to the first. So I would say that this is the limit as x approaches negative infinity of a 2x over x minus 1 over x over x plus 1 over x. And you can see I have a 2x minus 1, 2x minus 1. They're just both divided by x, x plus 1, x over x plus 1 over x. Then I would simplify this. So this is the limit as x approaches negative infinity. 2x over x is just 2 minus a 1 over x. And then this is a 1 plus 1 over x. Now when I actually reevaluate the limit, I'm plugging in a negative infinity. This would be 2 plus 1 over infinity. And this would be 1 minus 1 over infinity because I'm plugging in a negative. This goes to 0, and this goes to 0. It actually equals 2. So for this one, I have an asymptote at y equals 2. Now, there is another way to do this, and I'm going to do that as we do the limit as x approaches positive infinity. So if I do the limit as x approaches a positive infinity of 2x minus 1 over x plus 1, you can tell what happened here is that what we call the dominant terms survived the canceling, and the lesser terms did not. So what happened is this x matters a lot more to the graph than this minus 1. As you get out towards infinity, this is like 2 times infinity, which is a lot. Then you're just subtracting 1. This is the dominant term, and the denominator, the x, is the dominant term. If I only look at the dominant terms, I have a 2x over x, and that actually reduces to a 2. So I'm showing the same asymptote either direction, so it's really just one asymptote. But 2x over x, you do want to make sure that you've got all the signs in the right spot. So here, if this is a positive infinity, everything's great. Negative and a negative would cancel out as well, which is why there's just one. But sometimes, you know, you might be tempted just to do one limit as x approaches infinity and not actually check both directions, and you might miss an asymptote that way.